All right, this is part 2 video on function graph analysis. We've already done domain, range, and behavior, evaluating from the graph x-intercepts, y-intercepts, minimum, maximum, and increasing, decreasing. All right, and now we're going to do it all again with this graph. So here we go. First of all, the domain. You can probably see that this graph goes left forever and it goes right forever. When there's no arrow on here, you guys, you're supposed to assume that it goes forever. When it goes right to the edge of the graph like that, you're supposed to assume that it keeps on going in that way. Okay, so because of that, this goes to the left forever and it goes to the right forever. Therefore, the domain is negative infinity to positive infinity. In a similar way, the range is also negative infinity to positive infinity because it goes down forever and it goes up forever. So the range is negative infinity to positive infinity also. Now the end behavior. The end behavior is all about what happens on the ends. All right, and there are two ends. We have this end over here on the left and we have this end over here on the right. Okay, let's start with the left. And basically you should be thinking in your mind, does it rise or does it fall? Well, on the left here it rises. So you should be thinking the graph heads towards positive infinity. On the right end it falls. So you should be thinking, okay, it goes towards negative infinity. But we have to be a little bit more mathematical than that. So the end behavior, instead of just saying, oh, on the left, we say as x approaches negative infinity. But that's a fancy way of saying as we go to the left. Now, what we just saw was as we go to the left, all right, the graph approaches infinity. It goes up forever. So we'll just finish this off with infinity. F of x approaches infinity. And again, this is a fancy way of saying as we go to the left, the function heads to infinity. Okay, now let's talk about the right. What happens as we go to the right? Well, here's how we word it. As x approaches positive infinity, because that means as we go to the right. And then what happened to the graph when we went to the right? Okay, as we went to the right, the graph headed towards negative infinity. So that's what we'll put. Okay, f of x approaches negative infinity. So as you can see, everything here in blue never changes. If you have an end behavior problem, it's always going to start out as x approaches negative infinity, f of x approaches, and then it's going to go as x approaches positive infinity, f of x approaches. And just understand, the negative infinity version, that means as we go to the left. And if it rises, that's going to be positive infinity. This one with the positive infinity, this means as we go to the right. And then the function approaches. And if it falls, you put negative infinity. All right, so that's end behavior. Now let's get on with the evaluating. Okay, please understand that function notation is in this form. F of x equals y. So whatever's inside the parentheses is an x value, and whatever's out here is a y value. All right, that's important right now because that 1 right there, it's in the parentheses. Okay, so that means this is an x value, and you're being asked to find the y value that goes with it. So fine, if this is an x value, all right, x equals 1, let's go to an x value of 1 and look around. Okay, so here's an x value of 1. I'm sorry, that's negative 1. Okay, somebody keeps picking values that are right on the line. I want to see some other values, man. Here's an x value of 1 right here. Now, at this x value of 1, the function is actually right on the line. So, so this is the point 1, comma 0. Okay, so we already had that x value of 1, but now we see that the y value that goes with it is 0. So we have f at 1 is 0, which you could also write as an ordered pair, like 1, comma 0. Now the next one says f of negative 1. So we need to see what happens at negative 1. And x value, remember, this is the x value, and they're asking us for the y value. So let's go to an x value of negative 1 and look around. Just going to erase this stuff. Okay, so here we are at an x value of negative 1. Now the function is above this, so I'm going to have to go up to see what's going on. And it looks like the function has this value at negative 1. Okay, specifically this is the point negative 1, comma 2. So you're seeing that at an x value of negative 1, the y value is 2. So that's the answer. That's what we're looking for. Okay, at an x value of negative 1, the y value was 2. And you could write it as an ordered pair, negative 1, comma 2. Okay, what about the x-intercepts? All right, the x-intercepts are the zeros of the function. Okay, so the x-intercepts are here and here. So that's negative 2, comma 0, and 1, comma 0. Okay, what about the y-intercept, or septs? Well, the y-intercept is where the graph touches the y-axis, and there is only going to be one of them. So here's the y-intercept, and that is the point 0, comma 4. Okay, what about maximum and minimum? And sometimes they call this absolute maximum. Okay, if there is an absolute maximum, it will be the highest point on the entire graph. Is there one? Maximum. No, there is no absolute maximum because this graph just keeps going up and up and up forever. So there is no maximum. There's no absolute maximum. So we will say none. Same problem with the minimum. There is no minimum. It goes down and down and down forever. So we would say none. All right? So then they can't ask us where the minimum is located, because that would be none, and they can't ask us where the maximum is located, because that would be none. All right? It doesn't apply. So these weren't very good questions for this particular graph. But I could have asked you this, and so make sure you understand this. Instead of just asking you for the maximum, I could have added one word in front. I could have said, what's the local maximum? And I could have said, what's the local minimum? Okay, that means even though it's not the highest point on the entire graph, this red dot right here is the local maximum because it's the highest point in this neighborhood. So the local maximum is 4. I'm talking y values here. So, okay, so there you go. Local maximum is 4. Now let's skip down and stay with maximum. So let's skip down to 23. Now where is the maximum located? Now remember, there was no maximum. So let's go ahead and talk about where is the local maximum located. Okay, so let's look back at it again. All right, so the local maximum was 4, but when I say where, I'm talking about the x value. And you know, this is the point 0, comma 4. right? So the x value is 0. So that's where. Okay, so where is the local maximum located? Well, it's located at x equals 0. Now let's go back to number 22. Where is the, no. Let's go back to 21. First the question said, what's the minimum? There was no minimum, so we're changing it to say, what's the local minimum? Is there a local minimum? Well, let's see. There is a local minimum. Erase this junk. The local minimum is right here. So even though it's not the lowest point on the graph goes way down here, this is the lowest point in this area. So that makes it the local minimum. And how high is it? Well, it's right on the x-axis, so it has a height of 0. Okay, so the local minimum is 0. Okay, now, where is the minimum located? Well, there was no minimum, so where is the local minimum located? When they say where, I'm asking you for x values. Okay, so let's look at that local minimum and talk x value. So there's my local minimum. Well, guys, this is the point -2, 0. Okay, the -2 is the x value. So that's the where, -2. So where is the minimum located? It's located at x equals -2. Yeah. Okay, and we already talked about where the local maximum is. All right, let's finish up this little group here by talking about increasing and decreasing again. Now be careful. This graph has more than one decreasing interval. So be careful to see what's happening. So as we journey along this graph, here's what's going to happen. Remember, we have to go from left to right. So we're going to start off on the left. So on the left, we start off from positive infinity. We're coming in from up high. And the first part of the journey, we're going down, down, down. This is a decreasing interval because of the way I'm falling. But then things change right here, and I start heading up for a while. So this green part of the graph represents an increasing interval until right here, where it changes again, and then I'm back to going downhill again. Okay, so this is a decreasing interval. All right, but once again, we need to talk about the domain of these parts. Domain, so I'm talking x values once again. Okay, so let's see. First, we'll do increasing. So let's look at the green part of the graph. All right, the green part, that's the increasing part. But please, just give me the domain, okay? You should only be looking at x values. So the green part of the graph just goes from here to here, x value wise. So in other words, the domain of the green part, on the left it goes to -2, and on the right it goes to 0. Okay, don't say 4, that's a y value. We're talking x values, left, right. All right, on the left it goes to -2, and on the right hand side it goes as far as 0. So that so we're going to say -2 to 0 for the increasing interval. And I think I'll do it in green just to color coordinate. So -2 to 0. For these increasing and decreasing intervals, we're going to go ahead and leave them as parentheses because we're not going to include the border line. Okay, because right here between decreasing and increasing, right on the curve itself, right on -2, it's neither increasing nor decreasing. It's actually flat at that one point. And same thing here. So do not include the borders. So therefore, round parentheses. Now decreasing. Be careful, there are 2 decreasing intervals. Okay? One for each of these red parts of the graph where we went downhill. So let's do first things first. Let's start with the one on the left. Now, this red portion, we need, this is a decreasing interval, but again, we need the domain of it. Okay? We need the x values that go with this. So if you looked at this red arrow and I said, what's the domain? I'm hoping you would see that the domain is -infinity to -2. All right, because this arrow here goes left forever. So that's -infinity. But on the right, it stops at -2. Okay, so when you're doing these intervals, we're reading left to right. So -infinity to -2. So that's one of them. All right, one of my decreasing intervals. Okay, so -infinity to -2. Okay, let's look at the other one. Whoops. Now look at this red part of the graph on the right. Again, we are looking for the domain of this arrow. How far left does it go and how far to the right does it go? All right, so again, don't say 4. That's how high up it is. I want to know how far left does it go. Well, I'm hoping that if you stare at it long enough, you will see that this represents the domain of this piece. Because this graph goes left, I mean the red part here, goes left to 0, you know, like it comes from the y-axis. But then it goes right forever, so 0 to positive infinity. Okay, so that's another increasing part of the graph. 0 to infinity. Okay. All right, so that's the end of this portion. So I'm going to go ahead and stop the video right here. This is long enough. On the next video, part 3, we will flip over to the back and we will evaluate some functions.